Okay, now let's go over the derivative of regular logarithmic functions. So for question number 1, I want you to find the derivative of log base 3 of x. Now before that, let's look at the formula that we need to know for taking the derivative of log functions. So if I have log base a of u and I want you to take the derivative of this, what the formula is going to be is it's going to be u prime over u times the natural log of a, and a is going to be whatever the base of our log is. I'll show you in a minute how this is going to relate to the derivative because it's very close, if you notice, to the derivative of natural logs. We just have this ln of a when we have a different base. So I'll go through that in a second. So let's look at the log base 3 of x. And let's identify what u is. So u in this example is going to be x. U prime is the derivative of x, which is 1. And a is the base of the log, which in this example it's 3. So according to the formula, u prime would be 1 all over u, which is x, times the natural log of a, and a is 3. So that would be the derivative of that log function. In the case of, so we already did the derivative of natural logs, right? So a derivative of a natural log, we said that the derivative of a natural log, actually let me change this to u. We know that the formula for the derivative of a natural log is u prime over u, right? That was the formula that we had to memorize for our natural logs, which is the same as our logs, except we have to add on the base of a. Well, watch what happens in the case of natural logs. With natural logs, I have a base of e. So I could say, okay, I'm going to use this formula up here because this is just a log with base e. So u prime over u times the natural log of whatever the base is e. Well, we know that the natural log of e is 1. So that's why that when we take the derivative of a natural log, we're going to get u prime over u. When we take the derivative of a log with any base other than e, it's going to be u prime over u times the natural log of a. So let's look at some examples of this. So differentiate log base b of x. So again, let's identify u is equal to x. U prime is the derivative of x, which is 1, and a is the base of my log, which is b. So the formula, again, is going to be the derivative of a log is going to be u prime over u times the natural log of a. So this one, y prime, is going to be u prime, which is 1, over u times the natural log of whatever my base is, and my base in this example is b, and that would be the derivative. Okay, let's look at this example here. So u is equal to the argument of the log, so 7x squared plus 4. U prime is the derivative of 7x squared plus 4, which would be 14x, and a is my base, which is 3. So y prime is going to be equal to u prime over u, so 14x over 7x squared plus 4 multiplied by the natural log of the base, and the natural log of the base would be 3, and that would be the derivative. I'm going to give you some more examples that I want you to write down. So let's add, so we'll just call this will be example 1, example 2. Okay, find the derivative of log base 4 of x squared. Now for this one, I'm actually going to show you 2 different methods that we could do for this one. So again, what I've been showing you is identify what u is. U prime is the derivative of u, which would be 2x, and a is going to be the base of the log, which is 4. So the derivative is going to be equal to u prime over u. So u prime is 2x over u, x squared, times the natural log of the base, which is 4. And then from here, I could simplify, and it's going to be 2 over x times the natural log of 4. Let me show you an alternate way that you could do this exact same question. So find the derivative of log base 4 of x squared. We could move that 2 into the front, and we're taking the derivative of 2 times the log base 4 of x. This will give us 2 times, and then u prime is going to be 1 over u times the natural log of the base. This will give me 2 over x times the natural log of 4, which is the same answer that I got up here. Okay, let's do a couple more. Let's do number 4. So number 4, I want you to try this one. So differentiate with respect to x, log base 7 of 5 minus 2x. So try that one. And then I want you to do number 5. And that's going to be find the derivative of log base 5 of tan of x. Okay, so for number 4, remember that our formula is u prime over u. So u prime is negative 2, is the derivative of negative 2x over u times the natural log of the base, which is 7. So that would be my derivative. This one here, I'll just identify what u is. So u is tan of x. U prime is the derivative of tan of x, which is secant squared of x. And a, which is my base, is 5. So the derivative of log base 5 tan of x is going to be u prime, which is secant squared of x over u tan of x times the natural log of a, which is the natural log of 5. I'm going to give you your homework right away. We will finish this in a different video. But before I do that, I want to go back to natural logs for a second. And I want to do one more example of a natural log. So we'll do this as class example 6. So what is the derivative of the natural log of ln x? What is the derivative of the natural log of ln of x? So I've got a natural log within a natural log. Or basically, this is the argument of this natural log. Now remember, if we have natural logs, what our formula is going to be, it's going to be u prime over u. Remember that I could also say the natural log of a, which is the base, but the base is just e. So the natural log of e is just 1. So when we take the derivative of natural logs, our formula is going to be u prime over u. Okay? So let's figure out what that will be. U is my argument. So it's the natural log of x. U prime is the derivative of the natural log of x, and we know that the derivative of the natural log of x is 1 over x. So according to this formula, u prime over u, I would have 1 over x over the natural log of x. I've got a complex fraction, so what I want to do is I'm going to multiply, I want to get rid of this denominator of x. So I'm going to multiply top and bottom by x. I could put the x over here, like I could have put the x down here, but just make sure how we're going to write this is x over x will cancel to give us 1, and then x times the natural log of x. Okay, so that would be the derivative of the natural log of ln x. All right, for your homework to practice taking the derivative of regular log functions, I want you to do question number 3, and I want you to do question number 5, which is the left column. And then I've got 3 keyed. So number 3 is taking the derivative of log functions. Number 4, we're not going to do just yet. We got to wait till we finish that off. And then number 5, I want you to try as well. So for number 5, I want you to do A and C.